Hello, we're looking at checkpoint 3.45 from section 3.7. They want us to use the inverse function theorem to find the derivative of the inverse of tangent. So if this is g of x, then the inverse of this, we'll call it g inverse of x. The derivative, the inverse of the tangent inverse is the tangent function again, so that's a tan x. All right, so that's our first step. Now we want to find the derivative of that, g inverse prime of x, and that's the derivative of tangent, which is secant squared of x. And then finally, putting this into the formula, we're going to get g prime of x, so that's the derivative of that is equal to 1 over secant squared of not just x, but in for x, we're going to put the original function, which is tan inverse of x. So what have we here? This would be, seems like it would be a fine answer, but it turns out that this can be simplified, and in trigonometry there's a lot of different formulas that you can approach this. And so what we want to do is we want to see if we can rewrite this as something with less trig functions. So what we want to do is we want to create a relationship between the tangent inverse of x and some angle and a triangle. So if we let theta equal to the tan inverse of x, then we can say that tan theta is equal to x. And from here we can create a triangle. And so let's create the triangle right here. And by a triangle, I mean a right triangle, so we can do our trigonometry. And if we identify one of the angles to be theta, then the tangent is going to be the opposite over adjacent. So there's no denominator here, so let's assume that the denominator is equal to 1. So the opposite is x, the adjacent is going to be 1. And we can complete this triangle by figuring out what the hypotenuse is. And if you use Pythagorean's theorem here, it's just going to be 1 squared plus x squared. So then that would be that. Now we further dive into trigonometry and realize that the secant of some angle theta, more specifically it'll be this angle tan inverse of x, the secant is 1 over cosine, which is going to be the opposite or adjacent over hypotenuse. And so the secant would be hypotenuse over adjacent. So let's just say hypotenuse, let's say this is going to be the hypotenuse divided by the adjacent sides when we're talking triangles here. So the triangles that we're considering, the sides are going to be the hypotenuse over the adjacent. So secant of theta is going to be the hypotenuse side. That's a square root of 1 plus x squared divided by the adjacent side. But we want secant squared, so we're going to square that. And we're going to square the square root of 1 over x squared, so secant squared theta is equal to just, well, let's write it out. So that's just 1 over x squared. This should be squared. Okay, so there we have it. The g inverse is going to be 1 divided by this expression, so let's do that. We can just say the g prime of x, which is going to be the derivative of the inverse tangent of x, will be 1 divided by the secant, because remember theta was equal to tangent inverse. So the secant of tangent inverse quantity squared is just going to be 1 minus x squared. So this is going to be the formula that you're going to essentially Actually, if we break it off here, this is the formula that we're going to get to remember for quicker access to finding derivatives of the arctangent. Okay, I hope that helps.